So, to follow up on the podcast that focused on the evolution of scenarios from SA90, IS92 to SRES, we'll now move on to RCPs, which became the norm for AR5, and then AR6 moved on to SSPs, even though SSPs were discussed partly in AR5 as well, and many ideas of SSP shared socioeconomic pathways were already there. So these are representative concentration pathways, and the change in philosophy also is obvious in going from SRES, where you talked about humor interventions, not so much about mitigation, carbon capture, bioenergy, and so on. It was much more focused on what has happened in the past and where we are going in the future, with obviously many assumptions about scenarios for the future in terms of population, energy, and so on. But these are much more detailed, complex, and complicated. Does that make them more realistic, or does this just indicate another way that IPCC has yielded to political demands? Even if it did, is it a good thing? Is it a good thing that IPCC works with governments and decision makers and politicians that they can co-produce the future scenarios? And then who makes sure that decisions follow and action follows after these talks about scenarios for the future, right? So the representative concentration pathways and overview starts with this abstract, which I'll read in case you get bored and quit halfway through. This paper summarizes the development process and main characteristics of the representative concentration pathways, a set of 4 new pathways developed for the climate modeling community as a basis for long-term and near-term modeling experiments. The 4 RCPs together span the range of year 2100 radiative forcing values found in the open literature, so goes from 2.6 to 8.5 watts per meter squared. 2.6 is the most benign one, which is likely to keep us below 2 degrees C, warming above pre-industrial level by 2100, with some probability of something like 66%. The RCPs are the product of an innovative collaboration between integrated assessment modelers, climate modelers, terrestrial ecosystem modelers, and emission inventory experts. Integrated assessment models have received their own criticisms. I have podcasts on whether these are the right tools or not, and what are the various assumptions in them that can cause problems in relying on them for future projections, as well as whether they were forced to make assumptions that are not really valid to meet these demands for these pathways. There are some papers arguing that some of the assumptions they make on bioenergy and carbon capture, for example, are not completely consistent with their own model capabilities and were just added to meet these demands for scenarios. Okay, the resulting product forms a comprehensive data set with highly spatial and sectoral resolutions for the period extending to 2100. Land use and emissions of air pollutants and greenhouse gases are reported mostly at a half degree by half degree spatial resolution, which is order 50 kilometers, with air pollutants also provided per sector for well mixed gases and a coarser resolution used. So in these later assessment reports, impacts due to individual greenhouse gases were included as well. The underlying integrated assessment model outputs for land use, atmospheric emissions, and concentration data were harmonized across models and scenarios to ensure consistency with historical observations while preserving individual scenario trends. For most variables, the RCPs cover a wide range of existing literature. The RCPs are supplemented with extensions, so extended concentration pathways, ECPs, which allow climate modeling experiments through the year 2300. What's the value of that? Are they even meaningful beyond 2050? Already scenarios have a big role to play in the uncertainties of the evolution of temperatures and everything else. But there are some interesting things to look at, life cycle or residence time of CO2 carbon is much longer than a century, so going out to 2300 would get us towards some sort of a equilibrium if we manage to curtail the emissions in the 21st century, let's say. And sea level rise, glacier melts will continue as well, so there is some interest in looking at what happens in out to 2300. The RCPs are an important development in climate research and provide a potential foundation for further research and assessment, including emissions mitigation and impact analysis. That's also kind of new compared to where we started in 1990. The IPCC also decided such scenarios would not be developed as part of the IPCC process itself, leaving new scenario development to the research community. So it was partly outsourced from the framework of simulating the various scenarios. The community subsequently designed a process of 3 phases, which is reported in this Nature paper, I think, by Richard Moss. Development of a scenario set containing emission, concentration, and land use trajectories, referred to as representative concentration pathways. A parallel development phase with climate model runs, and development of new socioeconomic scenarios. So socioeconomic pathways already part of the development of RCPs, even though the assessments reported in AR5 were all mostly about RCP scenarios. A final integration and dissemination phase, so that happened. RCP development, overall description of the methodology. In order to benefit from the progress in climate model development of the past decade, the climate modeling community requested additional information from integrated assessment models, IAMs, than was available from previous scenario exercises. This is where there is some debate about whether IAMs stayed true to their model capabilities. Representatives of the IAM modeling community worked together with representatives of the climate modeling community and others to facilitate the data transfer, so laid down in a protocol on data exchange, both as part of this process and based on discussions within the context of the IPCC. Several design criteria were established. These criteria follow from their intended use to facilitate research and assessment. The RCP should be based on scenarios published in the existing literature, developed independently by different modeling groups, and as a set to be representative of total literature in terms of emissions and concentrations. At the same time, each of the RCPs should provide a plausible and internally consistent description of the future. What this internal consistency means, you can read up. The RCPs should provide information on all components of the radiative forcing that are needed as input for climate modeling and atmospheric chemistry modeling, so emissions of greenhouse gases, air pollutants, and land use. This is where forcing by individual components came about. Moreover, they should make such information available in a geographically explicit way. So we'll see maps of emissions for the future in this sense. The RCPs should have harmonized base year assumptions for emissions and land use and allow for a smooth transition between analysis of historical and future periods. The RCP should cover the time period up to 2100, but information also needs to be made available for centuries thereafter. So you can already see that this process is remarkably different from what we discussed in the first podcast on the evolution of scenarios. Some of the points, additional points: 4 existing scenarios were selected from the literature. 4 scenarios were updated to reflect advances in integrated assessment modeling and to use common base year emissions and land use where possible. Preliminary releases by individual themes were subjected to internal review by the RCP research groups, so there's some iteration there. This process resulted in several rounds of revisions of the scenarios. Land use data of the RCPs were harmonized, so they were made consistent with the selected set of base year data, and downscaled were provided at half a degree grid. Emission data on the RCPs were harmonized and downscaled for air pollutants, so aerosols and tropospheric ozone precursors. The emission data were converted to concentration data using a selected simple carbon cycle climate model for well-mixed greenhouse gases and an atmospheric chemistry model for reactive short-lived substances. people also say short-lived substances like black carbon, for example. Simple extensions of the RCPs for the 2100 to 2300 period were developed. All relevant information has been made available for downloading by using a central repository. This repository allows the user to preview and download data on emissions, concentrations, and radio forcing and land use, both at the level of aggregated regions in gridded forms. So uncertainties are expressed in some ways. So here are the iteration processes that occurred in terms of RCP development. IAMs, which focus on socioeconomic scenarios, land use and land cover data, emissions, concentrations, and climate data, and gridded emissions. So here are the scenarios, and processing and completion of land use and land cover data, and then going into RCP repository, harmonized, and all the other good things done that we talked about. Available information from RCPs and resolution. I won't read all the details, but you can see emissions of greenhouse gases at various resolutions by sector and by geographical measure. CO2, methane, other greenhouse gases like N2O, HFCs, SF6, etc. Emissions of aerosols and chemically active gases. Also, sulfate related things, sulfur dioxide, black carbon, organic carbon, and the short-lived agents. Speciation of volatile organic compound emissions, concentration, so that goes into ozone precursor that we mentioned. Concentration of greenhouse gases, concentrations of aerosol and chemically active gases, ozone, aerosols, nitrogen deposition, and sulfur deposition, land use, land cover data. So for those who are modelers or deal with data, things like N deposition and S deposition are massively uncertain, as well as aerosols, direct and indirect effect sources, sinks, transports. So this is not an easy task, but nonetheless accepted consent models, consensus models, and quantities are used. So cropland, pasture, primary vegetation, secondary vegetation, and forests. So sectors include energy, industry, land, etc., with various subgrid fractions, so annual maps in transition matrices, including wood harvesting. So the main point I'm trying to make is that imagine the kind of assumptions that go in and the uncertainties that they bring to the projections at shorter time scales and at longer time scales. This is a huge challenge, especially if massive investments are being based on such projections. That's a value call you have to make in terms of how decisions have to be made about risks that exist, and then interventions and investments have to be made, keeping in mind discounting of the future and so on, some of which I have discussed elsewhere. Overview of representative concentration pathways, RCP 2.6 to 8.5. So these numbers 2.6, 4.5, 6, and 8.5 refer to the additional radiative forcing that would result by 2100 with a corresponding CO2 equivalent number, and you know that CO2 equivalent corresponds to CO2 plus non-CO2 greenhouse gases converted to CO2 forcing with global warming potential. And there is some debate about that as well. 100-year period is used to convert the forcings to CO2 baseline, but that's not accepted by all. Okay, so you can see here RCP 2.6 ends up with peak in radiative forcing at about 3 watts per meter squared, with approximately 490 ppm CO2 equivalent before 2100, and then decline with selected pathways to 2.6 watts per meter squared by 2100. So there are overshoots and then declines, which depend on various assumptions about bioenergy, carbon capture, transitions in policies, socio-technical transitions, and so on. So here are the various references to papers and models. What do we end up with? So here is the population projections going into these in millions. How reliable are these? I always worry because as women get educated and more financial independence for women, fertility rates are dropping everywhere. And this is the paper from 2011. China has just reached its peak population and is failing to incentivize women to have more kids because women don't simply have kids for money, right? And so on. So you have to keep that in mind. And then GDPs. So this is GDP in 2000 US dollars for each scenario, and you can see that RCP 2.6 has kind of a co-benefit. Even though emission is lower, GDP grows faster than others because climate change has severe negative impact on GDPs. But looking at where we were in terms of SRES, you can see the range is reduced in RCPs, especially for GDPs as well, because the warmings. Is this better constrained, more constrained? Are we relying on technological promises of bioenergy and carbon capture and sequestration too much? Well, that's a debate, right? So primary energy consumption, again, I won't go into the detail, but you can see the mix of energy that are used and how oil consumption is phased out in different scenarios. So the most benign scenario has to start phasing out oil consumption very quickly in terms of exajoules, but it still doesn't go to zero by 2100. So you have solar, wind, geothermal, hydro, bioenergy, nuclear, natural gas, oil, and coal. So coal still remains here in the business as usual scenario of RCP 8.5, but also in RCP 2.6 it's not phased out completely in 2100. The problem, of course, is when you look at these scenarios and you see the impact of the pandemic and the Russian invasion of Ukraine, you imagine that making up scenarios is good, but it's very difficult to know how things play out, right? So we have to keep that in mind because these geopolitical perturbations and pandemics affect economies and recoveries and climate action, as well as investments in renewables and progress towards global warming targets. Other things, carbon factors, so kilogram calories per gigajoules. So you can think of it as carbon intensity of energy. So obviously has to drop to zero and even negative by some time in the most benign case, and here is the middle of the way RCP 4.5, and that is 8.5, and there are reasons why RCP 6 overshoots and comes back, but I won't go into that here. But again, we have SRES scenarios which are much beyond the range from RCPs. Energy intensity in gigajoules per dollar, so that's the GDP. Energy intensity of GDPs, they all have to drop, and we looked at this in a different format in the SRES development, but here you have renewables plus nuclear for various time scales and various scenarios, fossil fuels without carbon capture and sequestrations, and fossil fuels with carbon capture and sequestration. What do you do with it? You look at the trajectories, but remember that if we end up having successful carbon capture and sequestration at scale, which doesn't exist still, will that serve as a motivation to continue to dig out fossil fuels and burn them? Will we be able to keep fossil fuels in the ground if carbon capture is touted as a savior by, let's say, energy companies, and hence they begin to sell, and poor countries and others will continue to buy oil? Very complicated issues. Some more details. Area in millions of hectares for cropland. Here's the historic trend and then future. Grasslands, vegetation. What are the uncertainties in these, especially in the outer decades? We have to live with that, right? Similarly, CO2, methane, and N2O for the various scenarios, and you can see SRES are here in dotted lines, but business as usual goes way over here in terms of CO2, methane, and N2O, and RCP 2.6 has to go zero or negative for CO2, but methane and N2O will continue, which means to reach some of the global warming targets, there has to be negative emission technologies. In other words, there will be irreducible emissions of, let's say, methane and N2O, but we have to draw out more than we are emitting. Is it possible, or is it a technological promise that may not be fulfilled or not guaranteed to be fulfilled? Make your decision. These are SO2 emissions and NOx emissions. Won't say much other than that uncertainties for these will be higher than CO2. CO2 is well mixed, long lasting gas compared to N2O and methane, but easy to measure accurately and precisely. But that's not the case for all these other non-CO2 gases. Be as that may, we end up with a map for RCP 2.6 to RCP 8.5, and you will see that India and China get blamed in business as usual as well as in the most benign ones. This again depends on various assumptions going into the future, but considering that Canada and the US and Australia have not been, or even Russia have not been very diligent about signing on to Paris Agreement and steps after that, can we continue to hammer the countries that are participating and signing on to agreements and submitting their nationally determined contributions and revising them and investing in renewables and so on? Well, that's the way it works for the global south, right? So here is what we end up in: trends in concentrations of greenhouse gases. So there are emissions and there are concentrations. Concentrations are what remain in the atmosphere, which means there are big assumptions about where the carbon that we emit ends up going in the ocean, land, and so on. So those uncertainties remain, plus whether the models include carbon feedback to climate or not. Many details that are hidden in these things. Okay, nonetheless, business as usual will get us to some of the concentrations that haven't been seen for tens of millions of years, and the most benign scenario will bring us below where we are right now, but we are headed in a la-la land already, and the emissions are not bending yet, so these are dream scenarios still. Similarly for methane and NOx. Okay, these are the radiative forcings. We already talked about them, so we end up with 8.5 overshoots and back here, for example, middle of the road, and the ranges. Okay, so RCP 6 again has kind of here RCP 4.5 overshoots and comes back for various internal feedback kind of reasons. So these are the emissions versus radiative forcing from literature, which were used for developing scenarios and iterating with integrated assessment models. And here are the individual components adding up to radiative forcing going into the future to 2100. So extension of RCPs, I won't spend too much time. As I said, the value of these is not clear. The reliability is definitely a big question, but nonetheless there is some perceived value for those, and you can see the radiative forcings associated with that. What are the main characteristics of each RCP? Scenario component: greenhouse gas emissions, agricultural area, air pollution. So RCP 2.6 very low, medium for cropland and pasture here, medium and low for air pollution. In RCP 4.5, which is typically referred to as middle of the road pathway, we have medium to low mitigation of greenhouse gas emissions, very low baseline here, very low for both croplands and pasture in terms of agricultural area. What is not explicitly discussed here is if bioenergy and carbon capture and sequestration are part of these pathways, then the competition for food production versus bioenergy production, food security issues, water issues, equity issues, where the land will come from, and so on, are all kind of hidden away in these. Air pollution would be medium in this case. Medium baseline, high mitigation for greenhouse gas emissions, medium for cropland but very low for pasture, totally low for agricultural area in RCP 6. So there is area and then there is emissions. Agricultural emissions are already being discussed a lot in terms of how to reduce their emissions, which contribute about 25% of the total right now. How will they be reduced? What are the approaches? And what will we manage to get done? Okay. Air pollution will be medium here. RCP 8.5 has a high baseline. So baselines are not all the same in this case. So that's something we have to remember as well. Agricultural area will be medium for both cropland and pasture. The implications are many here. I'm just reading them off, but you need to follow up the paper and other literature for more details if you want these. I obviously tend to be very brief. Air pollution will be medium to high. I think this podcast is long enough, so I will stop this and continue this in the next podcast and conclude the rest of the story of evolution of RCP pathways in the next podcast. Okay?